Welcome to the fascinating world of sustainable hygiene manufacturing, a journey that begins with natural banana fibers, carefully extracted from agricultural waste and transformed through innovative, eco-friendly processes into high-quality hygiene products. From raw plant material to finished goods, discover how nature, technology, and responsibility come together to create a cleaner future. Our journey begins not in a factory, but on banana farms, just after the harvest. Once the bananas are collected, the banana plant completes its life cycle. What remains is the pseudo-stem, a thick, water-rich structure weighing between 30 and 40 kilograms. For decades, these pseudo-stems have been considered agricultural waste and left to decompose in the fields. Today, they are given a new purpose. Collected directly from local farmers, these stems are obtained at no cost and must be processed quickly. With a moisture content of over 90%, freshness is critical. The pseudo-stems must be treated within 72 hours to prevent natural fermentation. This is the very first step in transforming agricultural waste into safe, sustainable, sanitary products. Once the banana pseudo-stems arrive at the processing site, preparation begins immediately. Each stem is first split lengthwise, either manually or using a semi-automatic cutting machine. This initial cut reveals the internal structure of the plant, composed of multiple protective layers known as sheaths. On average, a single pseudo-stem contains around 11 layers. These layers are carefully peeled by hand using knives, allowing workers to separate the fiber-rich sections from the non-fibrous material. Not all fibers are the same. The outer layers produce stronger, more rigid fibers, while the inner layers provide softer, finer fibers, better suited for hygienic applications. Once prepared, the banana stem sheaths are transported to a modern processing facility in the United States. Here, agricultural material collected from abroad enters a controlled industrial environment. The next critical step is fiber extraction. Using decortication machines, the prepared sheaths are fed into rotating rollers that mechanically separate the fibers from the softer, non-fibrous pulp. In some cases, manual extraction is used alongside machinery to preserve fiber integrity and ensure consistent quality. After extraction, the banana fibers still contain traces of sap, pulp residue, and fine particles. Before they can be transformed any further, they must be thoroughly cleaned. Inside the facility, the fibers are washed with clean water to remove remaining impurities. This process improves both hygiene and fiber quality. In some cases, the fibers are immersed in water for extended soaking. After washing, the fibers still contain a significant amount of moisture. To ensure stability and prevent spoilage, drying becomes essential. Depending on the season and weather conditions, the fibers are dried naturally under the sun for 1 to 3 days. Once fully dried, the banana plant fibers are ready for transformation. Inside the facility, the fibers are first cut into smaller segments to prepare them for mechanical processing. They are then introduced into a beating system similar to a Hollander beater, where controlled mechanical action softens the fibers and breaks them down into a uniform slurry. This process increases flexibility while preserving the natural cellulose structure essential for absorption. To ensure hygiene and safety, the fiber suspension is boiled. High temperatures eliminate microbes and stabilize the material for intimate use. The sterilized suspension is then diluted with water and further refined. Using advanced, often patented technology, the fibers are shredded into ultra-fine fluff, forming a highly absorbent pulp. At this stage, plant fibers are no longer visible as strands. They have become the core material used in sustainable sanitary products. The absorbent pulp now enters a critical stage, core formation. The fiber suspension is evenly deposited onto a fine mesh screen, forming thin, uniform sheets. These sheets are gently pressed to remove excess water and compact the cellulose structure. Drying follows inside solar-assisted dryers, operating at controlled temperatures between 60 and 80 degrees Celsius. Once dry, the sheets are mechanically
Flow rate is
pulverized
steady,
into
no
fine
clogs.
fluff.
Good. Let's keep an eye on the consistency. Pile height approaching limit, ready to adjust.
This fluff is then recompressed into continuous absorbent layers. Precision cutting systems shape the material to exact dimensions. Finally, forming dies press the absorbent cores into their final structure. What emerges is the functional heart of the sanitary pad, engineered for performance, consistency, and comfort. With the absorbent core complete, assembly of the sanitary pad can begin. Additional materials are introduced to ensure comfort and protection. A soft, biodegradable, non-woven cotton layer is used on the top, designed to remain gentle on the skin. Beneath the core, a compostable bioplastic layer, such as PLA, provides leak protection while maintaining environmental sustainability. The absorbent cores are placed onto a moving conveyor belt. As the line advances, the top and bottom layers are aligned and combined with precision. Compression units ensure proper bonding between layers. Ultrasonic sealing replaces traditional stitching, creating strong, clean seals without damaging the material. The assembled pads are then shaped and cut to their final form. In the final step, adhesive is manually applied to allow secure fixation during use. Each pad now meets the functional and structural requirements of a finished hygienic product. Before packaging, every sanitary pad undergoes strict sterilization to ensure hygiene and safety. In modern facilities, pads pass through UVC light tunnels. The ultraviolet light penetrates surfaces to eliminate bacteria and other microbes. After sterilization, the sanitary pads enter the final stage, packaging. Each pad is carefully folded, usually in 3 segments, to ensure compactness and ease of handling. Workers then place the folded pads into individual compostable pouches, sealing them hygienically. Once individually packaged, the pads are grouped into larger packs, ready for storage. The final packages are stacked neatly in climate-controlled storage areas, awaiting distribution. From raw banana pseudostem fibers to fully packaged sanitary pads, this process combines precision, hygiene, and sustainability at every step. You now know how sanitary pads are made. From banana stem fibers, blended with cotton and PLA, transformed step by step through modern manufacturing processes into the final hygiene products used by women every day. From raw natural materials to a finished sanitary pad, this process highlights how sustainability, technology, and everyday life are closely connected. If you've watched until the end, write banana in the comments. Thank you for watching all the way through. Don't forget to subscribe and let us know in the comments what manufacturing process you'd like to see next. Thanks again, and see you in the next video.